In this video, I'm going to show you how to find the magnitude of a vector, how to do some arithmetic with vectors, and then how to find a vector in a certain direction with a given magnitude. So to start with, let's find, let me talk you through my notation here. We have u is equal to 3i plus 4j. I always write this with these pointy parentheses. Because as you can see, my i's and my j's are hard to tell apart and it's messy, and so I always use this notation. You do not have to, that's just what I do. So I'm going to continue doing that. And then w is negative 2i plus j. I'm going to write that as negative 2, 1 in these pointy brackets. So we're going to find the magnitude of u. There's a formula for this, but I'm going to walk you through why that makes sense, or why it is the formula. If u is 3, 4, think about that as the ordered pair that the vector goes through. So go out 3 and up 4. And here's your vector. This is the ordered pair 3, 4. Well, that means that this height is 4, this width is 3. We know that this is 5, and that's the length of this vector, the magnitude. So the magnitude has to be 5. But let me show you how to get there. The magnitude of u, you do the square root of the x component squared plus the square root plus the y component squared. This is the Pythagorean theorem solving for c. If you were to do that, you would have c squared equals a squared plus b squared. Eventually, you would do c as the square root of those things. That's exactly what we're doing. So this would be the square root of 9 plus 16, which is the square root of 25, which is 5, and that's what we got. So the magnitude of u is equal to 5. Okay. For part B, we are going to do a little bit of arithmetic. So we're going to do 2u plus w. So I'm going to write this as 2 times that vector 3, 4 plus w, which is negative 2, 1. I'm going to distribute this 2. So I have 6, 8 plus negative 2, 1. Then I'm going to add the x component, so 6 minus 2. I'm going to add the y components. So I get 4 and 9, and that is equal to 2u plus w. All right, and last up, we're going to find a vector in the direction of w with magnitude 7. So w is negative 2, 1, so negative 2, 1, that would be this way. Here's your vector w. Well, I don't know what the magnitude is of w, so let's figure out what it is. The magnitude of w, remember this is the Pythagorean theorem, so we have negative 2 squared and 1 squared. That would be 4 and 1, so the square root of 5. That's the current magnitude, but I want the magnitude to be 7. So let's let v equal 1 over root 5 times my vector w, so negative 2, 1. This has magnitude 1. Because I have divided out by the magnitude. Magnitude was root 5. I divided the whole thing by root 5, so that means the magnitude is now 1. If I want the magnitude to be 7, I'm just going to multiply to get it. Let's just call this a. We'll call this 7 over root 5. So just multiply it in. This has magnitude equal to 7. If you don't trust that, let me do this on a different, we'll do this on a different page to show you that. 7 root 5, negative 2, 1. Seven over root 5 times negative 2, 1. And we want to find the magnitude. The magnitude should be 7. So I'm going to distribute this. Actually, should I? Yes, let's do it. So we get negative 14 over root 5 and 7 over root 5. We're going to find the magnitude. So I'm going to square the first part. So I have negative 14 over root 5 squared plus 7 over root 5 squared. 14 squared is 196. Root 5 squared is 5. 7 squared is 49. Root 5 squared is 5. 49 and 196 is 245. 245 divided by 5, I hope is 49. It is. And that's 7, which is the magnitude of that vector, so we did do it correctly. Okay, so that is just some basic stuff with vectors. If you have any questions, let me know.